Hello everyone, and welcome back to exercise number 43 of the SolidWorks basic tutorial series. In this video, we're going to be designing a flanged housing. Now, as always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature. However, also, when creating these drill holes right here, we're going to be using the hole wizard feature a lot. So in total, if we look closely here, we have 12 drill holes, 4 on this side and 4 on the other. That makes 8. Plus 4, and that makes 12. So we have 4 drill holes, and then we're going to be using the hole wizard tool right here. Here we see the schematic drawing for exercise number 43. All dimensions are in millimeters. We have the isometric view, the section view, and the section view showcases the internal details, the internal profiling of the component. We have the section view, we have the top view, and we have the side view. And of course, we have a question here that reads, what is the mass of this part in grams? And the answer should be provided within a tolerance of plus or minus 1 gram. As always, we also have a set of instructions. The instructions are self-explanatory and pretty obvious, but the key takeaway is that we need to use material of ASI 10-way steel in answering this original question. Also, we have a note here, 2 notes actually at the bottom, and it says that all unspecified fillets have radius of 3 millimeters. So unless otherwise stated, all fillets have a radius of 3 millimeters. And as well as any chamfers, if present, of course, and we do have chamfers here for this component. The dimensions of the chamfer should be 1 millimeter by 45 degrees. So we're going to be using the distance and angle convention. All right, so looking at the main features for the component, we see that we have, or actually this can be approximated by 4 consecutive cylinders stacked over each other. We have the first cylinder here representing the bottom boss, and then second cylinder should represent the flange for the component. The central hub would be cylinder number 3, and cylinder number 4 would be the top boss here at the top right here. Also, we have 2 cylindrical sides, in addition to openings for the 2 extremes of the components. If we look at the section view, we see that the distance between the 2 extremities of these openings over the side cylinders should be 120 millimeters. And that there's a line of symmetry acting along the y-axis for the component, all right? So we're going to be using the mirror tool a lot, especially in creating this these cylinders here at the side. Also, if you notice here, we have 12 drill holes. And this is where, I wouldn't say it gets tricky, but that's the special feature that we're going to be using. And looking at the note here, say that we have 12 drill holes, and each hole should is M4 or M4 type hole and 10 millimeters deep. All right. Also, for the flange, if you look at the top view, we have 4 mounting holes, and these 4 holes lie on a pitch circle with a diameter of 135 millimeters. And if you look closely, these 4 circles, these 4 holes, are positioned in such a way that the angle between the circle and the horizontal is 45 degrees. All right. So that's pretty much everything we have for the component. It's a relatively simple part to design, and we shouldn't have any problems. Okay, so with that aside, let's get started with exercise number 43. Okay, so let's start by creating a new SolidWorks part. We set the background to plain white, and let's copy exercise number 43 into SolidWorks. Let's go ahead and make this smaller. And as I said previously, the main strategy here to create the main body of the component actually is to model 4 consecutive cylinders over each other, right? So the first cylinder would represent the bottom boss here at the bottom. If we look here at the section view, we see that there is a boss at the bottom. The second cylinder would represent the flange for the component. The third cylinder would represent the main hub for the part. And the top boss here would be cylinder number 4. All right. So to start, let's go ahead and select top plane, sketch. Let's put this to the side, and let's go ahead and activate the circle tool. From the origin, let's draw a single circle. Activate the Smart Dimension tool, and we're going to work on creating the first cylinder here at the bottom, right? So if we look closely, we see that the diameter of the circle should be 100 millimeters. All right. So let's go ahead and assign that. This should be 100 millimeters. And then we need to extrude this 2D sketch to a overall height of 8 millimeters. All right. So press S on your keyboard, select Extrude Boss Base, set the end condition to blind, and enter a thickness of 8 millimeters, and then click OK. That creates the first cylinder. Now we're going to work on creating the flange, so go ahead and select this top face, sketch, activate the circle tool, and from the origin, draw a slightly larger circle. Activate the Smart Dimension tool, and if we look at the top view of the component, we see that this flange has an overall radius of 80 millimeters. So the diameter here should be 160, right? So this needs to be 160. Now we need to extrude this 2D sketch to a thickness of 10 millimeters. As you can see here, the flange has a thickness of 10 millimeters. So press S on your keyboard, Extrude Boss Base, enter a thickness of 10 millimeters, and then select or press OK. Right, and that creates the base profile or the base body of the flange. Now we're going to work on creating cylinder number 3, which represents the main hub or main body of the component here. So select this top face, sketch, activate the circle tool, and from the origin, draw another circle. Activate the Smart Dimension tool, and if we look closely here at the side view, we see that the diameter of the bottom boss here corresponds to the diameter of this middle section right here, right? So this right here, this circle should have a radius of 100 millimeters as well, or diameter of 100 millimeters. And now press S on your keyboard, Extrude Boss Base, and if we look at the side view, we see that this 2D sketch should be extruded to an overall height of 110 millimeters. All right, so enter a extrusion height of 110 millimeters, and then select OK. Finally, we're going to work on creating this boss here at the top. So select this top face, sketch, activate the circle tool, and from the origin, again, draw a circle, activate the Smart Dimension tool, and we can see here on the side view that this top cylinder should have a diameter of 80 millimeters. So this should be 80 millimeters. Press S on your keyboard, Extrude Boss Base. We need to extrude this 2D sketch to an overall height of 125 minus 10, which is 115, minus 110 to give you the thickness of this line, of the length of this edge, which should be 5 millimeters. All right. So go ahead and assign it an extrusion thickness of 5 millimeters, and then select OK. Now that creates the main body of the component. Now we just need to create certain openings. So if we look closely here at the section view, we see that we have an opening, a circular opening at the bottom that goes all the way to the top, specifically to a cut depth or at the top of to a depth of 120 millimeters. Don't pay much attention to this horizontal line here, simply tangent line. Okay, so don't get confused. So let's go ahead and select this bottom face, sketch, activate the circle tool, and from the origin here, draw a circle. Activate the Smart Dimension tool, and if we look closely at the section view, we see that the opening should have a diameter of 90 millimeters. So the diameter of this circle should be 90 millimeters. Press S on your keyboard, Extrude Cut, and we're going to cut this all the way to a depth of 120 millimeters. But before that, we need to set the end condition to blind. All right. And we need to write a cut depth of 120 millimeters. And then select OK. All right. Now we need to create this opening here at the top. So to do that, select this top face, sketch, activate the circle tool, and draw a circle. And if we look at the section view, we see that this top hole here at the top should have a diameter of 54 millimeters. So activate the Smart Dimension tool, and this should have a diameter of 54 millimeters. Press S on your keyboard, Extrude Cut. Set the end condition as up to next. And up to next means up to this inner surface at the bottom right here on the top. And then select OK. All right. Now, if we look closely here, we see that we have two cylinders on both sides of the component. And looking at the section view, we see that the overall distance between the two extremes here for the two cylinders is 120 millimeters. And since we have symmetry for the component along the y-axis, half of it should be 60 millimeters. So we need to create a new drawing plane that is exactly 60 millimeters away from the origin or the central line of the component. So what we need to do is very simply go to Features, select or go to Reference Geometry, and then select Plane. Here it's going to ask you for the reference plane that you want to use, and then we're going to select the front plane. All right, and we need to create a new drawing plane that is exactly 60 millimeters away from the front plane. And again, here's always set 60, and then select OK. Right now, very simply, just right click on this drawing plane and select Sketch, activate the circle tool, and going over the origin, move vertically upwards, and then draw a circle. This one's sure that the circle is directly overhead of the origin. So now just select this point and this origin and set the relation between the two as vertical. All right. Looking at the this side view here, we see that the circle should be 63 millimeters away from this bottom edge. So the distance between this circle and this bottom edge right here should be 63 millimeters. All right. And the diameter, if you look at the section view, the diameter of this circle should be 180 millimeters. Right. So this needs to be 80 millimeters. All right, so this is 80, not 180 millimeters. Now the sketch is fully defined. Just press S on your keyboard, extrude boss base, set the end condition as up to surface, and we're going to select this curved surface right here, and then select OK. Let's go ahead and hide this drawing plane. Let's now create the opening for the side cylinder here. So let's go ahead and select this face, sketch, and activate the circle tool and hover over this circumference right here to activate or wake up the central point. And from this central point, go ahead and draw a circle. Activate the Smart Dimension tool. And if we look closely at the section view, we see that the hole here should have a diameter of 54 millimeters. So this should be 54 millimeters. Press S on your keyboard, extrude cut. And we're going to set the end condition as up to next, and go ahead and select OK. All right. Now what we need to do, you see here that we have 4 drill holes on the surface, on the face of this cylinder. So what we need to do is actually create a pitch circle, okay, to help us assign the position of these 4 drill holes. So go ahead and select this face, sketch, activate the circle tool, and starting from this center, we're going to draw a circle. Convert this circle to a construction geometry, and then activate the Smart Dimension tool. And if you look closely here at the side view, we see that this pitch circle should have a diameter of 65 millimeters. So go ahead and assign a diameter of 65 millimeters. All right. Now exit sketch, go to Features, Hole Wizard. And if we look closely at the side view, you see here that we have 12 holes, 4 on one side and 4 on the other. That's 8. And we have 4 at the top here. Overall, it should be 12. Okay, and the type of drill we need to use is M4, and it's 10 millimeters deep. All right, so we need to select the straight tap hole here. We're going to use the ISO standard, and the size here is set to M4, and the depth of the hole should be 10 millimeters. All right. Now go ahead and select position, and here's going to ask you for the face that you want to drill on, and then select this surface right here. All right. And we're going to assign one of the position for one of the holes right here, and then select OK. Now we need to create the other 3 copies. So what we need to do is select circular pattern. And here it's going to actually just ask you for the direction. Let's go ahead and select this outer circle. The overall copies need to be 4, and then select OK. Now we need to hide this construction geometry. Now what we need to do is very simply mirror what we did here to the other side. So go ahead and select mirror. For the reference, go ahead and select the front plane. As for the features to mirror, just go ahead and select certain faces. So you have this face, as well as these two faces right here. All right, and then select OK. Now we need to create the drill holes here at the top as well. So go ahead and select this top face, sketch, draw a circle starting from the origin. Let's convert the circle to a construction geometry. Activate the Smart Dimension tool. And this needs to have a diameter of 65 millimeters. And we're basically repeating the same process in creating these drill holes as we did with the other two faces right here. So now go to Hole Wizard. We're going to set the cut depth or drill depth to 10 millimeters. As for positions, I'm going to select this face. And that's pretty much it. And select OK. Go to linear pattern, circular pattern, direction right here, and select OK. Let's go ahead and hide this line right here. So right click on this and select hide. All right. Now, if we look closely at the top view, we see that this flange here has 4 mounting holes. Okay, and these mounting holes lie on a pitch circle with a diameter of 135 millimeters. And these 4 holes here are actually 45 degrees relative to the horizontal. All right, they're equally spaced. So to start, we're going to have to select this top face. So go ahead and select this top face, sketch, activate the circle tool, and starting from the origin, we're going to draw a circle. Activate the Smart Dimension tool, and we see here that the pitch circle should have a diameter of 135 millimeters. Convert this to a construction geometry. And what we need to do now is draw 2 center lines, one horizontal center line, and another center line here at an angle, starting from the origin, at any angle right here. Activate the Smart Dimension tool, and we see here that the angle between these 2 lines should be 45 degrees. Okay, activate the circle tool, and starting from this point, the intersection point right here, we're going to draw a circle. Smart Dimension tool again, and if we look at the top view, we see here that we have 4 mounting holes, and the diameter of each hole should be 10 millimeters. So this needs to be 10 millimeters. To create the other 3 copies, very simply go to Linear Sketch Pattern and then select Circular Sketch Pattern. Entities to pattern, we go ahead and select this circle and then select OK. And that creates the 2D profile or 2D sketch for these 4 mounting holes. Press S on your keyboard, extrude cut, set the end condition as through both directions, and then select OK. All right, now that creates the 4 mounting holes. Now, if we look closely here, we have a circular profile, a circular opening. So what we need to do is very simply just select this top face, sketch, activate the circle tool, and then we have, starting this point, draw a circle. Activate the Smart Dimension tool, and the diameter of this circle should be 30 millimeters. Now we need to mirror this circle to the other sides, but before that we need to draw a vertical center line. So starting from the origin, draw a vertical center line. Select this vertical line and this circle, press S on your keyboard, and then select Mirror. That will automatically mirror the circle to the other side. Press S on your keyboard, extrude cut. Notice here how we've been using the S key a lot in this tutorial. Saves a whole lot of time. Then select OK. All right. So that creates the main body or main features of the component. Now we just very simply need to apply the chamfers and fillets whenever needed. And if we look closely here at the notes at the bottom, it says here that all unspecified fillets have a radius of 3 millimeters. So wherever edge here that has a fillet and the fillet radius is unspecified, by default it's going to be 3 millimeters. And the chamfers, all the chamfers here have a dimension of 1 millimeter by 45 degrees. So we're going to select the distance angle convention. So let's go ahead and first of all apply the chamfers. So the chamfers here should be 1 millimeter and the angle should be 45 degrees. Now, as for the chamfers, we first of all have this bottom edge and this top edge right here. These are two edges that have chamfers. And if we look closely here, we see that this edge has a chamfer, right? Look at the section view, also has a chamfer. And we have a chamfer here at the bottom as well. And then select OK. Now let's select fillets. Now there are certain fillets that have a radius of 5 millimeters. For example, we have fillet here at the top and a fillet here for the flange of the component. So we have a fillet right here. And we have a fillet here as well. And select OK. Every other fillet will have a fillet radius of 3 millimeters. Okay, so by default, we're going to enter a fillet radius of 3 millimeters. And if we look closely here, we see that the inner edge for the hole has a fillet, and the fillet is 3 millimeters. So what we need to do is select this edge and the other edge as well. We have this edge as well right here. And we have what else? Let's see. Yeah, that's pretty much it. And we have this edge right here between the two cylinders. And then select OK. Set the view to perspective. We need to make sure that we've got all the fillet edges that we need. Yeah, I think that's pretty much it. Now, very simply, we need to ensure that we need to apply a material of ASI 1020 steel and then determine the mass of the part. So go ahead and delete this image. Apply material. Right-click here, edit material. Select ASI 1020 steel. Apply, close. Now, go to Evaluate, Mass Properties. And if we look closely here, we see that we have a final mass of 3,248.4 grams. So basically, approximately 3,248 grams. That is the final answer. Okay, so that concludes exercise number 43. Hope you all enjoyed this video. If any comments or questions, please leave them down in the comment section below. I hope to see you all in exercise number 44. Until we meet again, bye-bye.